Okay, in this video, I'll be deriving the classical intensity of blackbody radiation. It's also called Rayleigh Jeans Law, or Rayleigh Jeans Law. And here I have the general equation for intensity. There's constants, and then it's multiplied by the average energy of all modes. So what is differing from classical equation and the modern equation is the average energy of all modes. This is the continuous version. So the Boltzmann distribution equation says that the average energy of all modes is equal to these two integrals. And this is using statistical quantum mechanics. So the first step is to solve these integrals. I'll start with the one on top. Now, that could be a pretty complicated integral. However, there's Fynmans integral trick for this specific one. When you have the integral of xe to negative alpha times x dx from 0 to infinity, the answer is 1 over alpha squared. So notice that both of the limits are from 0 to infinity, and then we have a constant times e to something, and then here we have constant times e to something, and the something is negative alpha times x, and then here we also have negative alpha, which is just a constant, 1 over kt times x, which is epsilon. So in this situation, our alpha is equal to the constant up here, which is 1 over kt. So using Fynman's integral trick, the top portion of this should be one over kt squared. And then to simplify this is 1 over 1, which is equal to 1. Now, it's top, bottom, bottom, top. So now that we've used this integral trick, we can get rid of it. Okay, so like I said, kt squared times 1 is just kt squared. And then 1 times 1 is just 1. And then on the bottom, we still have this integral to solve. And this is a little bit simpler integral. All right. To solve this integral, we'll want to use U substitution. So we have the integral of e to the something. So we're going to say u is epsilon over kt. That means that du is equal to the derivative of this. So the derivative is just 1 over kt. Now we want to multiply, we want to get this to the other side. So we multiply kt by both sides. So d epsilon is equal to kt du. So here we substitute d epsilon for du, kt. Now, this is an improper integral, so we have to do the limit as b goes to infinity. First, we want to take the integral. So the integral of e to the u is e over the derivative of u, so it's just -1, and then this is still kt, and it's evaluated from 0 to infinity. So now we want to do the limit as b approaches infinity. Of kt so this is going to be negative kt e, and then you put in b for the variable. Evaluated from 0 to infinity. This is equal to the limit as b goes to infinity, approaches infinity, negative kte to the negative b minus the negative okay. Now we have the limit as b approaches infinity, and then here as e goes to negative b, you're not able to evaluate that. So what we want to do is do negative kt over e to the b. And when you put e to the b underneath, you lose this negative sign. It's this rule. That's the rule we're using. and then plus e to the 0 is 1, so minus a negative is a positive, so we just have kt. Now as e goes to the infinity approaches 1, so wait, that's incorrect. E to the infinity gets infinitely large, so this just goes to 0. So the limit as b approaches infinity is just equal to kt. And kt squared over 1 is just kt squared. And then we solved for this integral, and we got kt. So 1 kt squared over kt is just kt. So you get epsilon is equal to kt. Okay, now we have the general equation for intensity again. And now we can just plug in epsilon. And this is the Rayleigh Jeans Law. And that's the classical intensity for black body radiation.